Okay, so case 4. The object is at F. So we can't go in through F, obviously, this time. So case 1 ray, in parallel to the principal axis, gets bent in such a way that it comes out through F on the other side of the lens. And the second one, a ray that goes into the optical center. Goes straight through. Okay? And just ignore this little piece right here. Alright, I have to use the same two from the bottom. A ray going in parallel to the principal axis. Oops. It's going to get bent up and then bent up so that it comes out through F on the opposite side of the lens, and a ray that goes in through the optical center, doesn't bend, and goes straight. So if you've noticed, these cases are paralleling the mirror ones, and so what you should see here is that these, the refracted rays do not cross. They are parallel. And so what that means is no image. Just like there was for that case in the mirrors. All right, next case, the object between F and the lens. So here's my object from the top. A ray going in parallel to the principal axis is going to get refracted in such a way as it's going to go through F on the opposite side. And then a ray going in through the optical center is going to go straight through. From the bottom, maybe I'll do optical center first. A ray going in through the optical center will go straight through. A ray going in parallel to the principal axis gets bent up so that it goes through F on the other side. Where these are diverging, which means if you follow them back, you will find out that they cross somewhere back here. Where the purple cross, that is where the head is going to be. Where the green cross, that is where the feet. So this time the image is over here. Image is, it's right side up, so it's virtual. It's erect. It is definitely larger. And it is the same side as object. Okay? And if you look at these, they parallel exactly to the ones with mirrors. And since they do, we may as well do our one diverging case. So our one diverging case, put it anywhere on one side of the lens. All right, and the rays are similar to the rays we're using for the diverging mirror. A ray going in parallel to the principal axis. It's a little tricky. Will get bent in such a way that if you were to follow it back, it would look like it was coming from F. That one's a little tougher. The one through the optical center is always good. It doesn't bend at all, so a ray going through the optical center will go straight through. From the bottom, a ray going through the optical center will go straight through. A ray going in parallel to the principal axis will get bent in such a way that if you follow it back, it will look like it was coming from F. Okay? So where do they cross? This is where the purple one crosses, right here. And this is where the green one crosses. So check out our little image. He's right side up. Which means he's virtual. Erect. Smaller. And same size as the object. Same side. Whoops, what am I just writing there? Same side as the object. Too many S's while I was writing. Same side as object. Okay? So just like the mirrors, there are two ways that you can get a virtual image. One is with the converging lens, with the convex lens, and that virtual image will be larger. And the other way is with the diverging lens, the concave lens, and that virtual image will be tinier. Okay, so when the question says it's a smaller virtual image or a smaller erect image, then it means you're using diverging. But if it says bigger, it means you're using converging. Okay, and we will come back and talk about the rays here for the concave one in a couple of minutes or in the next video, whichever comes first. But before we move, let's just go back to case 1. And what I'd like to do is go through them and say, where have you seen this one being used? Because all of these we use. So this one, where the object is large and the image ends up being tinier and on the other side, this lens we often use in cameras, right? Because we're taking a picture of a tree, and if this was the olden day camera, this was where we would put the film, right here. And if you ever look at the negatives of an older camera, you would see that everything was inverted. Okay, so this lens is inside a camera. It's also inside our eye, and the spot where the image is formed is where our retina is, and it's always upside down. But I jump ahead. That I will do a separate video on how the eye works. Case 2, in what contraption, piece of equipment, do you put an object some distance from a lens and get an image that's the same size and equidistance? This one is the lens in a photocopier. In a photocopier, this is the piece of paper you put in the photocopier that you want to copy, and this is the piece of paper that passes underneath the lens, the glass in the photocopier. It passes underneath the lens equidistant apart, and the image is formed the same size. If you want to do an enlargement, or if you want to reduce it, maybe if you've ever stood there and pressed the button, the positive and negative, to make it bigger or smaller, you might hear a noise in the machine, and that noise is the noise of the lens moving closer one way or closer the other. And it's why that photocopiers can only enlarge or reduce things to a certain point, because there's only a certain amount of space the lens can move to get it either closer, like where so the object's beyond 2f, or to get it so the object's between f and 2f. Okay, but normal photocopier, it starts out with the object at 2f. All right, case 3, when is the object close to the lens and the image ends up bigger and further away? This is a projector. Before you were born, there was something called a slide projector, and you'd get these little slides and you had to put them in a carousel and shine them on the wall. And when you did that, if you put them in right side up, the scenes would become upside down on the wall. So you always had to put the slides in upside down. Okay, but this is a projector. Case 4, this one's really cool. You might think, well, when do we ever pass something, put an object somewhere, and then the light comes out parallel and there's no image, and when would that be useful? This is the lens in our car lights. And we don't want an image to be formed. We just want the beams of light to come out parallel. Imagine if an image was formed